All right, so part two of this is going to be more about the measuring aspect, and it has to deal with the instruments and the instruments that we use in our lab. And this is kind of the basis of our lab that we will be doing in class on Monday. So none of the instruments that we have, definitely not that we have, can read to an infinite number of decimal places. So we have to use the instrument that has the least uncertainty. So the question is, of these three instruments, which has the greatest uncertainty? And you may recognize the one on the left as a triple beam balance. The one in the middle is more like a butcher shop uh, scale. And then the one on the right is a old looking but very precise analytical balance with 3 decimal places, which is really hard to reach. Now, you can't see all the specific details, but for the most part, I hope you would guess that the butcher scale is the least um, certain. It has the greatest uncertainty. And let's talk about what that means. So, what you can title this is significant figures and measurements. And so we are going to be looking at measuring. And you should be able to, by the end, explain what significant figures are in a measurement and determine the number of significant figures in any measurement. And that's actually not for today, number 2, but we will be doing the first one. So significant figures include all of the digits that are known plus one last digit that is estimated. So the numbers that we can report, whether they're the ones that are actually measured and known or estimated, are limited by the tool itself. So the question is, if we are looking at this graduated cylinder, how many significant figures are there in a measurement? So let's talk about it. This is what you should kind of jot down, some but not all of it. There's not a lot of notes for this, just letting you know now. But if we look at this, okay, so we've got this graduated cylinder and they've enlarged it on the right. So every measurement has some degree of uncertainty. So the volume is where the blue is up to. Okay. Now, if we look at that, you can see that there is definite certainty that it is between 10 and 20. Okay. You can also tell that it is certain that it is between 17 and 18. But the uncertain digit is the tenths place. So if we look at this, you know for sure it's between 10 and 20. And then you know for sure it's between 17 and 18. And then reading at the bottom of the meniscus, you have to make your best guess on the tenths place. So you will always have an estimation for your last digit. So whatever your smallest increments are, your uncertain digit will be what you are estimating between. And I'd say that maybe is about 0.6. So, to indicate the precision of a measurement, the value recorded should use all the digits known with certainty plus one additional estimated digit, and it's considered uncertain by plus or minus 1. And then after that, there should be no further digits. You can only measure as far as the device will allow plus 1 uncertain. The last significant figure is the estimate. So if we look at these two measurements, they're for the same object. It's the same quantity, but it's being described at two different levels of precision and certainty. And what you'll notice about this is the plus or minus. So if we are looking at the first number and our uncertain digit is the 7, which is in the hundredths place, that is why our plus or minus is in the hundredths place. Now over here, we have our 8 is our uncertain digit, and it is plus or minus to whatever that is, tenths, hundred thousandths, 10,000ths, 100,000ths place. You probably know better than I do. So that is for balances and glassware. Now, if we were reading this meter stick, for example, we know that it is past 2. We know that it is past 0.7. The question is, what is that third digit? Because we need to estimate between the 7 and 8. Okay, it's not all the way to the 7, it's not all the way to the 8. So it's probably somewhere between 0.05 and 0.08. So our reading will be 2.77. So we've estimated the last digit because it's between the last two markings that are on our meter stick. If you said 2.76, that's fine as well. If you said 2.78, that's fine, because that is an uncertain digit. We're estimating that. So we knew the 2 and 7, and the third digit is estimated. All three digits are significant, even though the last one has been estimated. Here's another one. If we look at this, okay, we know it's more than 9. We know it's less than 10. We know that it is at least 0.3, but it is not all the way to 0.4. Is it 9.31? Is it 9.32? Is it 9.33? I guess I would take any one of those. I would lean more towards the 0.32, but again, it's an estimate. Now, 0. This is probably one of the things that bothers people the most, but if it is exactly on a line, it's 0. And if it is just before the line, it is 0.9. You have to read. So if you look at this line, it's definitely more than 4. It's not more than 5. It looks like it's for sure 5 point something, but it's right on that 5, which means the second digit must be 5.0 because it doesn't go beyond the 5. It's not all the way to 0.1, definitely. But this meter stick can actually be measured to the hundredths place. So the last digit is 0 as well. So there's 3 significant digits here, because we know for sure the 5, we know that it is not all the way to 0.1, so it's 0.0, and then we're estimating that last digit, but since it's right on the 5, it's not really too much of an estimate. Now, let's do this one. So remember, always estimate one place past the smallest mark. So if we look at this picture, we have our meniscus about right here at the bottom. Okay, now we know it's greater than 10. We know it's less than 15. Okay, this is a hard one because you really have to figure out what the markings are. So if the large marking is 10, then this must be 11, right? You can't quite see 12. This is 13, 14. 12 is maybe about right there. Okay. So all of these little markings then are 0.5, correct? So this is 10.5, 11, 11.5, 12, 12.5, 13, and so on. So if you were to have a reading, it's between 0.5. So you would have to guess somewhere between 0.5 and the next number up. So think about what your answer would be. Make sure you read at the bottom of the meniscus. 11.5. So you are reading to that marking that is there. And I actually would even go a step further and perhaps even say 50. What about this one? It's definitely between 50 and 60. It's definitely greater than 52. It's not all the way to 53. 52.8 would be my approximate guess. So if we look at that, again, it's not all the way to this 53. It's just below it. And again, we're not reading up here. That's the top of the meniscus. We're reading down here at the bottom of the meniscus. So it's just a little below 53. Now, this is a burette. And you read a burette the opposite direction. So on this last one, it was low to high. On this one, it's the reverse. So if you're looking at this, make sure that the first thing you do is you see where your numbers are. So the lower number is up here, the higher number is right here. So you're reading in this direction. And you might remember this from your lab equipment online activity. So if this is 4 and this is 5, then this is 4.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So we know it's 4.8. And then it's just a matter of estimating that last digit between 4.8 and 4.9. And then, make your best guess. What's your estimate there? My estimate is 4.85. I think it looks like it's right in the middle there. So now, our lab. You have a handout that is titled The Quality of Laboratory Measurements, and that is the lab that we will be starting on Monday. So you have a couple of different tasks. So if you're looking at these notes, it must mean either A, you're finished with your lab, or B, you have an egg group and you just need to come back and check tomorrow. But what you're going to do is after these notes that you've just taken, you're going to start a new page and do a new table of contents entry. And the name of our lab is The Quality of Laboratory Measurements. And your pre-lab is you are going to read the intro to the lab. You're going to make a materials list, and you're going to sketch the equipment, and you are going to create a flow map for each part of the lab. And I want you to skip the data part for right now. So just wait on the data table part because we're going to do a little something different. So skip that. But the other parts I definitely want you to do. And so the pre-lab questions are right down here. And again, you need to read the introduction so that you can answer those. And that will be due on Monday. And that's when we will start the lab.